Okay, today we are going to talk about half-life, which is the last part of nuclear chemistry. The term half-life, I think, is fairly self-explanatory. It is simply the time required for 1/2 of the atoms of a radioactive nuclide to decay. We've already talked about types of decay and radioactivity, so now we've got some time restraints to this. And I think one thing to remember when we're talking about half-life is we have to have a knowledge of fractions. If we have a substance and we represent the original amount by the number 1, if it undergoes 1 half-life, we're going to cut that original amount in half one time. Okay, so we would have 1/2 of the original amount if I use my little pie here. Okay, bad pie, bad circle, but you get the picture. Now, if we cut that in half again, okay, we're going to go from 1/2 of the original amount to 1/4 of the original amount. Alright, so all we would have left here, if we take our half and we cut it in half again, we end up with 1/4 of the original amount. Hopefully you see the pattern here. If we go through a third half-life, we would get to 1/8 of the original amount. So again, if we use our circle, we take that quarter of the pie, we cut it in half again, we'd get to 1/8. We would then go to 1/16 if we underwent 1, 2, 3, 4 half-lives, so we would cut that piece of the pie in half again. Okay, so that's the basic concept with half-life, is that how long does it take to cut things in half. Now we're going to see some math problems related to these types of scenarios, and there is not a really simple plug-and-chug type of equation. It's much more at looking at what is given to you, what is known, and then using some math skills to solve that. Okay, so let's look at the first one and really look at what they tell us, or the known part of the problem. Alright, phosphorus-32 has a half-life of 14.3 days. Okay, so that's how long it's going to take for phosphorus-32, half of it, to decay. Okay, it wants to know how many milligrams remain. Alright, so we got to figure out what we have left over. If 57.2 days have passed, and we start with 4.0 milligrams. Alright, so let's do our organizational chart. If we think about the known, what did they tell us? Well, they told me that half-life is equal to 14.3 days. So that's how long it's going to take to go past. I know that my original amount was 4.0 milligrams. I also know that 57.2 days, oops, try to spell this correctly, are going to have gone past. Alright, what's the unknown? What am I looking for? How many milligrams are left after all of that process has gone by? Alright, so first of all, I have to figure out how many half-lives. Now, there are several different ways to do this math. I'm going to show you one way, but if you have something else that works for you and you can demonstrate how you get the answer, I'm totally fine with that. But my first step is going to figure out how many half-lives went past. So what I'm going to do is take my 57.2 days, which was how much time went past, and divide it by the half-life of 14.3 days. Excuse me. Alright, if I take 57.2 divided by 14.3, I get 4. So that means that 4 half-lives have passed. Okay, now I'm going to run out of room, so I'm going to go to a new slide here. But the important information that we're going to take with us, so to speak, is that we start with 4.0 milligrams, and we have to figure out how much is left when 4 half-lives go by. Alright, so let's draw this kind of like I did before. And this is the long way, but just to show you where all this math comes. If I take 4.0, which has 2 significant figures, by the way, so that's how many is going to be in our answer. If I cut it in half one time, and I kept the number simple here so that we could understand it. If I cut it in half one time, I would have 2 milligrams. So if 1 half-life had gone past, I would have 2 milligrams. When that second half-life goes past, I'm going to take that 2, and I'm going to cut it into 1 milligram. When that third half-life goes past, I'm going to take that 1, cut it into, actually I'm not keeping my significant figures here, 0.50 milligrams. And last but not least, I have to undergo a fourth half-life. So I'm going to take that 0.50 and I'm going to cut it in half again and get to 0.25 milligrams. And that's my final answer. Alright? Hopefully we recognize it's got to be less than 4, because that's all I started with. But another way you could have done the math is if I took 4.0, I also could have multiplied it by 1/2 raised to the 4th power. This is absolutely a situation of for you to use whatever system works best for you. lots of different ways to show this math. You can draw me some pictures as long as they're labeled and they're identified, but that's how we get there, and 0.25 milligrams is our final answer. Okay, let's look at one more practice problem. It says if a nuclide has a half-life of 7.50 years. So we start to list out our known stuff here. Our half-life is equal to 750 years. We want to know, taking up a lot of space with my known and unknown, but that's right. I want to know how long, okay? So what's the time for 3/4 of it to decay? Alright? Or in other words, only 1/4 remains. I'm going to run out of space. So 1/4 left. Okay, now the thing with half-life problems is they're always going to give you enough information. We're not looking for the amount of material, so they didn't give it to us. They're just looking for time. So all I have to figure out again is how many half-lives it's going to take for 3/4 of it to decay, and then take that and multiply it by 750 years. So let's do this on the next slide. Alright, again, if I conceptually go back to my fraction stuff, if I go from 1 and 1 half-life, I'm going to have 1/2 left. After 2 half-lives, I'm going to have 1/4 left, okay? Which means that 3/4 of it will have decayed. So for example, if I use my little pie chart again, after that first half-life, 1/2 of it will be gone. After the second half-life, oops, I'm a little off here in my drawing, another 1/4 of it will be gone, so 3/4 will have decayed and 1/4 will be left. So all I have to do to take my math is take my 750 years. Now if I go back for a second, the way 750 is written like this, there's only 2 significant figures, so my answer is only going to have 2 significant figures. I take that and I multiply it by 2. Alright, now I don't use my 2 to limit it because it's just would kind of be what we would consider to be a constant, I guess. And on my calculator, I'm going to get 1500. So if I leave it just like this, without any decimal places, I can have 1500 years, or if I want to use scientific notation, it'd be 1.5 times 10 to the 3rd years. And that's how long it would take for, see if I circled that correctly, for 3/4 of it to decay. Again, no plug and chug, which sometimes is a little bit more difficult, but we can still solve these problems using some simple graphing, or excuse me, simple fraction understanding. Okay, any questions?